Okay, they're asking us to use a calculator to evaluate these, and for A, they're asking us to evaluate ln of log, so natural log of the common log of 0.675. Now, when I type that in the calculator, I'm going to get an error. It just says non-real answer, and the go-to is not going to be a whole lot of help. So let's take a look at what's going on here. I'm just going to get rid of the ln part and type in, okay, so when I just evaluate log 0.675, that common log of 0.6, I get a negative number. Now, we cannot have a negative put into a logarithm. If you think about the question, what power do we raise any base to get a number? We'll never have a 0 power or a negative power. The thing that is inside the log. Let me try this again. So let's take a look at B. What power do I raise 5 to get 8? That number has to be positive, because when you think about exponents evaluating, your answer to an exponent is always positive. Okay, so this one, you're just going to type in capital D and E, because we have a negative. That's negative, so the natural log can't calculate. Okay, it says use the calculator to evaluate. Now, I want to show you the change of base, because we can use the calculator to evaluate this as common log of 8 divided by common log of 5. Or we can do the same thing with natural log. They work exactly the same way. Or we can use the change of base, the log of any base function on the calculator. Now, in the next chapter, they're going to ask you for change of base, and you're going to have to type it in explicitly, so it's never too early to start talking about that. Here's what I mean. We can type natural log of 8 divided by, and we want to close that parentheses on the natural log of 5. And we can do that same with the common log. Exact same number. We can also go to the math, and at the bottom is log of any base, so that A is log of any base. So I can type in a base 5 of 8 and get the exact same number. The nice thing about change of base is that the higher number goes in the numerator, and the lower number, the number in subscript, is in the denominator. And I guess we should probably write down an answer. 0.1292. I noticed that XYZ has us rounding to 3 decimals. 1.1292. 1.292. Okay, same thing with this. I'm going to just go back to the calculator, and if I second enter, it's going to give me that. Actually, let's clear that. Let's just go to math, log of any base. Okay, so it's asking me for log base E of pi. That's kind of interesting. E is the secondary function above the divide, so I'm going to second E. Right arrow to get out of that base. And then pi is above the caret key, second pi. And I do recommend you use those instead of rounding, because I'm not sure rounding to the 3 decimals what would happen. 1.145. Okay. Find the value of x. So here we are going to solve logarithmic equations by applying the exponent of the base. All right. And on A, my implied base is 10. So the first thing I'm going to do is take both sides, exponentiate both sides to 10th power. 10 is 10 as the base. And on the right side, I get just log base 10 of x, which simplifies to x. I don't usually write that solving step on the right-hand side. So when I go into my calculator, 10 to the 0.873, use that caret key, going to round to 3 decimals, 7.464. All right, same idea here, but I'm going to apply, look, I have a logarithm on the left side, a common log on the left, and a natural log on the right, but the natural log on the right is just a number. So same idea, I'm going to apply base 10 to both sides. On the left side I get x, on the right side I get 10 to the ln of 6. Back to the calculator, 10, caret key, and then I'm going to put in ln 6 in the exponent. 61 point, looks like 910. Rounded to 3 decimals. Log base 4 of x equals -2. So again, I'm just going to apply the base, same base as the log on the left-hand side. That'll simplify to x. 4 to the -2 on the right. So I get x equals 4 to the -2, or 1 over 4 squared, which is 1 over 16, which simplifies to 0.625. Okay, that's enough for this video. We'll see you on the next one.